Welcome to Daily Papers, the podcast where we break down the latest and greatest research into bite-sized, easy-to-digest chunks.
Today, we're diving into the world of cybersecurity and looking at a problem that affects almost everyone who uses software. It's called a software supply chain attack.
That sounds pretty serious. What is it, exactly?
Imagine you're baking a cake and you buy all your ingredients from a trusted supermarket. But what if a saboteur snuck in and contaminated just one bag of flour? You'd use it, bake it into your cake, and only find out there's a problem when it's too late.
So a software supply chain attack is like that, but for code.
Exactly. Programmers don't write every single line of code from scratch. They often use pre-written blocks of code called packages from public libraries. One of the biggest for the Python programming language is called PyPI, the Python Package Index. It's like a giant free supermarket for code.
And attackers are sneaking malicious, contaminated packages into this code supermarket.
You got it. These packages look legitimate, but they secretly contain malware that can do all sorts of nasty things, like steal your passwords or data. The number of these attacks is skyrocketing, and it's a huge challenge to find and remove these malicious packages before they do any harm.
Which brings us to today's paper. One detector fits all, robust and adaptive detection of malicious packages from PyPI to enterprises. The authors are trying to build a better security scanner for this exact problem.
Right. And they point out that current scanners have two big weaknesses. The first is that attackers are getting really good at disguising their malicious code.
How do you disguise code?
It's a technique called obfuscation. They essentially scramble the code to make it unreadable to automated scanners without actually changing what it does. Think of it like a spy in a movie putting on a wig and a fake mustache. They still have the same mission, but they're much harder to recognize. The paper calls these adversarial attacks because the code is specifically designed to fool the detector.
So the bad guys are actively trying to outsmart the security systems. What's the second weakness?
The second weakness is that not all users of a detector have the same needs. Think about the people who run PyPI, that huge code library. They see tens of thousands of new packages uploaded every day. They need a detector that is super precise. They can't afford to have hundreds of false alarms, or what the paper calls false positives.
A false positive is when the scanner flags a perfectly good, safe package as malicious, right?
Exactly. If the PyPI maintainers have to manually check hundreds of false alarms a day, they'll run out of time and energy. In fact, PyPI tried a malware scanner a few years ago and had to shut it down because it was creating an overwhelming number of false alarms.
But what about a security team at a big company?
Their situation is different. They might only be monitoring a few hundred packages that their company uses. They would probably be happy to check a few false alarms each day if it meant they had a much higher chance of catching a real threat. They can tolerate a higher false positive rate in exchange for better security.
Okay, so we need a detector that's not easily fooled by disguises and one that can be adjusted for different users. So how does this paper solve that? What's their big idea?
Their big idea is a technique called adversarial training. It's basically a fight fire with fire approach. To make their detector smarter, they first had to think like an attacker.
So they created their own sneaky, disguised malicious packages?
Precisely. They took known malicious code and used all those obfuscation tricks, scrambling it, encoding it, rewriting it in weird ways to create a whole library of adversarial examples. Then they used these examples to train their detector.
It's like they're training a guard dog by having people in disguises try to sneak past it over and over again. The dog learns to spot the tricks.
That's the perfect analogy, and it works. The paper shows that this adversarial training made their detector 2.5 times more robust against these sneaky attacks compared to a standard detector.
That's a huge improvement. Is there any downside?
There is a small one. They call it a double-edged effect. While the training makes the detector much better at finding obfuscated, disguised packages, it makes it slightly worse at finding simple, non-disguised ones.
It seems to make the model focus so much on the tricks that it can sometimes miss the obvious.
Interesting. But given that attackers are using more and more disguises, that seems like a worthwhile trade-off. So that covers the robustness part. What about making it adaptable, the one detector fits all part?
This is where their system is really clever. You can essentially tune it. Think of it like a dial for the false positive rate, or FPR. If you're a PyPI maintainer, you turn that dial all the way down to 0.1%. This makes the system extremely cautious. It won't flag something unless it's very, very certain it's bad.
And what were the results in that scenario?
In their 37-day test, this super cautious setting found, on average, 2.5 real malicious packages per day while only generating about 2 false alarms. That's a workload a small team can actually handle.
And for the corporate security team?
They can turn the dial up. The paper tests a setting with a 10% FPR. In this case, when monitoring about 1,600 packages for a large company, the detector generated only about 1 false alarm per day for a security engineer to review. Again, totally manageable, and it gives them much broader security coverage.
So it really is one detector that can be tailored to fit completely different needs.
Exactly. And this isn't just theoretical. During their research and testing, the authors identified and reported 346 new, real-world malicious packages to the community. They put their detector to work, and it found the bad guys.
That's fantastic. So to sum up, the software we all rely on is under threat from malicious code hidden in public libraries. This paper presents a detector that is robust and adaptive.
It's robust because it learns from the enemy's own tactics through adversarial training, and it's adaptive because it can be fine-tuned for anyone from the volunteer maintainers of a massive public project to a dedicated corporate security team.
A powerful and flexible solution to a very modern problem.
And that's a wrap on today's paper. Thanks for tuning in to Daily Papers.